All right, so our topic for this video is going to be proofs with some quadrilaterals. Essential question: how are quadrilaterals used in a two-column proof? We're going to be trying to prove that certain things are special types of quadrilaterals here today. Our first example gives us a parallelogram. It says that ABCD is a parallelogram. And we know that AC is perpendicular to BD. Those are going to be our givens. And our goal here is to try to prove that that means that ABCD is a rhombus, actually. Now, just as a refresher, a rhombus is a quadrilateral with four congruent sides. So that's kind of our mission. We want to prove that all four sides of this thing are actually congruent. If we can do that, then we know it's a rhombus. Now, since it's already a parallelogram, we should know that AB is congruent to CD and that BC is congruent to DA, right? That's because all parallelograms have opposite sides that are congruent. That is the parallelogram opposite sides theorem. Now, let's see here. So right now we know that these sides are the same, these sides are the same. Our goal is to try to get all four sides that are going to be the same. So what I'm going to do here is I'm actually going to focus in on these two yellow triangles. Because if I can get those two yellow triangles to be congruent, then I could use CP/CTC to say that AB is congruent to DA, and then I could substitute it in and know that all four sides are the same, right? Since we already know that AB is the same as CD, we already know that BC is the same as DA. So if I can get those two yellow triangles to be congruent, then I'm going to be doing quite well, and I should be able to prove that this thing is a rhombus. Now, if I can get those two triangles to be congruent, that means that I need to find three congruent things between those two triangles, right? So I can use side angle side or angle side angle or whatever. So I'm going to start gathering some congruent things here. One thing that I know right away, side AE is congruent to itself by the reflexive property. All right, so that is one congruent thing. Another set of congruent things that I could get that BE is congruent to ED. Sorry, let me mark what I've got there. I should know that this is congruent to this because of the parallelogram diagonals theorem. Remember, all diagonals and parallelograms bisect each other, according to the parallelogram diagonals theorem. So that is two congruent things. We need one more. How about those right angles, right? Those are right angles according to AC perpendicular to BD. That was in the given. So I'll say angle AED has to be congruent to angle AEB by definition of perpendicular. So that is three congruent things there. And now, if I've got three congruent things, I can say that triangle AEB must be congruent to triangle AED by side angle side, right? According to my markings there, I've got side angle side. And now I can finally say side AB must be congruent to side DA by CP/CTC. Since those triangles are congruent, then their corresponding parts are also congruent. So let me update my markings now. Now AB and AD are congruent, but I already knew that AB was congruent to CD. So by substitution, I can say that AB is congruent to BC, congruent to CD, congruent to DA by substitution property. And that means this thing's going to be a rhombus. So ABCD is a rhombus, since we have now shown that all four sides are the same, according to definition of rhombus. So just to make sure that that logic was clear there, I kind of took this step, combined it with this step to get that all four sides are the same. I already knew those opposite sides were the same, and then once I connected the dots by saying that AB is congruent to DA, that meant that all four sides were the same. All right, pretty cool proof. Next part says classify the given quadrilaterals as specifically as possible. I know that these look like squares, but if all we really know is that those opposite sides are the same, that means I can say it's a parallelogram, but nothing more. I know that that's also going to be true for a rectangle, but we don't know anything about the angles. This next one, according to the way that it was marked, that's definitely a kite. A kite's the only quadrilateral that has those two sets of consecutive sides being congruent. And then our last one, if we've got four right angles, that means it's going to be a rectangle. I know that it could be a square, but we don't know anything about the sides yet. So the only safe bet is to say that it's a rectangle. All right, let's go to the inside where example 3 has us trying to prove that this thing's a rectangle. So we know that ABCD is a parallelogram. And we know that AC is congruent to BD. Okay, now if we're going to say that this thing's a rectangle, we need to show that all four angles are congruent, right? All four angles need to be congruent if it's going to be a rectangle. Now, if it's a parallelogram, we should already know that angle ABC needs to be congruent to angle CDA, and angle BCD is congruent to angle DAB. And that is based off of the parallelogram opposite angles theorem. So I know that that's a lot of letters floating around. Let me do a little color coding. ABC is this angle, congruent to CDA this angle, and BCD is this angle, congruent to this angle. So we know that the red angles are congruent and the blue angles are congruent. We need to get all four of those to be congruent. If we can do that, then we win. Now, in order to do that, similarly to what we did last time, I'm going to focus on two triangles that use two of those angles. If I can get yellow triangle congruent to green triangle, then by CP/CTC, I can say that angle CDA is going to be congruent to angle BCD, and then I can use substitution to say all four of them are the same. So let's try focusing on gathering three congruent things between those two triangles, and then we would win. Now, conveniently, we already know that AC, this diagonal, is congruent to BD, this triangle. So I already have one congruent thing. So if I can get two more congruent things, then I'll have my triangles congruent. So two more congruent things. Both of those triangles share side CD down at the bottom. CD is congruent to CD, reflexive property. So I've got that. Now, since this is a parallelogram, we should know that side BC has to be congruent to side DA because those are opposite sides. So that's the parallelogram opposite sides theorem. That's this and this. Okay, and now we've got our three congruent things. So let's go ahead and say that triangle BCD is congruent to triangle ADC by side, side, side. And remember, the whole point of us getting yellow triangle congruent to green triangle was to get those angles to be congruent. So angle CDA must be congruent to angle BCD by CP/CTC. That was a CDA was a red angle. That was a blue angle. So now I've got a red congruent to blue, so that means that I can use substitution to say that all four are the same. So triangle A, or angle ABC, congruent to angle BCD, congruent to angle CDA, congruent to angle DAB by substitution. And then that means it's a rectangle. So ABCD is a rectangle according to the definition. So hopefully you followed the logic there. We already knew those opposite angles were the same, so we just had to go through a little bit of work to show that all four angles were the same. And then we got that by focusing on that yellow triangle and that green triangle. Down at the bottom, we're going to try to classify some quadrilaterals again. First one, we got four congruent sides. That means it's a rhombus, right? I know that would be true for a square as well, but for a square, we need to know that it's also got four congruent angles. Our next one has two opposite parallel sides and two opposite congruent sides, but they're not the same. So this is actually an isosceles trapezoid. And then our last one's got the four congruent sides and the four congruent angles. That is a square. All right. Last big proof here. We have been given a rhombus. ABCD is a rhombus. We've also got side AC congruent to BD. And those are those diagonals. They're giving us some congruent diagonals, and they want us to show that this means that this thing's a square. Now, in order to be a square, two things have to be true. All four sides have to be the same, and all four angles need to be the same. Now, conveniently, one of those is already taken care of for us. All four sides have to be congruent since it's a rhombus, right? Definition of rhombus says that all four sides are the same. So let's update our diagram here. We got all four of these sides being the same. Oh, and from the given, we already had that AC was congruent to BD. So now really it's our mission to prove that all four angles are the same. Now, since a rhombus is a type of parallelogram, we should already know that ABD, angle ABD is congruent to angle CDA, and angle DAB is congruent, oops, I didn't mean to put a congruency symbol there. Angle DAB is congruent to angle BCD. Now I know that when we got that many letters, it can be confusing at times, so let me do a little color code. ABD is really angle B, CDA is really angle D, DAB is angle A, BCD is angle C. We just got to use those three letters because we've got those little versions of those angles as well. And we knew that those opposite angles were the same because it is a type of parallelogram. Not definition of parallelogram. That is the parallelogram opposite angles theorem. Okay. Now, we know the opposite angles are the same. We need to show that all four are the same. So what we're going to do is very similar to what we just did on that last one. Let's go ahead and focus in on yellow triangle and green triangle. If we can get those two triangles to be the same, then we can say that those angles are the same, angle D and angle C. And then by substitution, we got all four. So let's do it. You know what? We already have those opposite sides being the same, side AD and side BC. So that counts as one thing. Let's grab saying DC is congruent to DC since they share that bottom side. That's the reflexive property. Oh, and you know what? I'm a crazy person. We already had the diagonals being the same. Side AC and side BD. So we actually know that all three sides of those triangles are the same. So let's get to it. Let's get those triangles being congruent. So triangle BCD is is congruent to triangle ADC by side, side, side. And that's going to be what lets us say that angle BCD is congruent to angle CDA by CPCTC. And let me do a little color coding here so that we can follow what I'm talking about again. If I lost you, that step was saying that the green triangle is congruent to the yellow triangle by side, 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 using those three congruent things that we've gathered. And now we actually get to say that we do have a blue angle congruent to a red angle by CPCTC. That's going to let us use substitution to say that angle ABC is congruent to angle BCD, congruent to angle CDA, congruent to angle DAB. By substitution property. And now, so that took this with this to make this. And now that we have all four sides being the same, because it was a rhombus, and now we have all four angles being the same after doing some substitution, now we can say that ABCD is officially a square according to the definition. Definition of square. Very cool. Okay, so a little more classification here. First one, we got a pair of sides that are both parallel and congruent. Hopefully you remember that that is one of the ways to prove that something is a parallelogram. Our next one, we got those diagonals that have been chopped into 4 equal pieces. That occurs in a rectangle and a square, but it's only safe to say that it's a rectangle because we don't know that those diagonals are perpendicular, or we don't know anything about the actual sides themselves. And lastly, we have a set of diagonals there forming a right angle, which occurs in a rhombus, a kite, and a square, but only that one diagonal is being chopped in half. So it's only safe to say that this is a kite. Okay, so your turn. You've got one that you're going to try to prove is a square again. So you should be looking really closely at that last one we did. Remember, to be a square, you need all 4 angles being the same and all 4 sides being the same. Since we are starting off with a rectangle, it is a rectangle, and AC is perpendicular to BD. Since you're starting off with that being the given, you should know that all 4 angles are always already the same, since that's a rectangle. And then you're going to try to get all 4 sides the same. So take a shot at it. I know these can be tricky. See what you can come up with. Really take a look at what we did on the last one. That should kind of stick you in the right direction. And then come back and see how you did. All right, so I would have started off by saying that since this is a rectangle, we already know that angle ABC is congruent to angle BCD, congruent to angle CDA, congruent to angle DAB, because that's in the definition of rectangle. Now, we also already know, since this is a rectangle, that AB is congruent to CD and BC is congruent to DA. That's because it's a parallelogram. So that's the parallelogram opposite sides theorem. So we've got those being the same, those being the same. Now we're trying to show that this thing is a square. So what we really need to do is show that we've got all 4 sides being the same. So I'm going to focus in on these 2 triangles. If I can show that those 2 triangles are congruent, that shows that DA and CD are the same, which would mean by substitution that all 4 sides are the same. So let me start getting some things being congruent between there. I know that DE is congruent to DE. That's the reflexive property. I know that AE needs to be congruent to EC because the diagonal gets bisected in a parallelogram. It's the parallelogram diagonals theorem. And on top of that, I got some right angles in there since those diagonals are perpendicular from the given. So I'm going to say that angle AED is congruent to angle DEC by definition of perpendicular. Okay, and that gives me my three congruent things. That gives me 1, 2, 3 congruent things. So those triangles should be congruent. So triangle AED is congruent to triangle CED by side angle side. And that's going to let me say that CD is congruent to DA by CPCTC. And remember, that was kind of one of our mini goals. Now we know that AB is congruent to BC, congruent to CD, congruent to DA by substitution. That was kind of taking this original statement and that one to get that. And that's going to mean it's a square. ABCD is a square according to the definition. Very cool. Okay. What else do we have going on down here? Classify the given quadrilaterals as specifically as possible. Oh, I don't have the right pictures on here for my screen. Which ones did you guys have? You had some different looking ones. Oh, you had the ones that look like this, and that was a parallelogram. Your middle one had this, and that should have been a rhombus. Rhombus has just those. And then your last one had this, which should have been a square. All right. Hopefully y'all got those ones right. And that's going to finish it off.